Factoring is the process by which we break down an entity into the things that multiply to make it. So, for example, 48. Two factors of 48 are 6 and 8, because 6 times 8 is 48. Two factors of x to the fifth are x squared and x cubed, because x squared times x cubed makes x to the fifth. Now, there's some special situations of factoring, the first of which we'll look at is the difference of perfect squares. When we're trying to factor something in the form a squared minus b squared, it's the difference because of the minus sign in between, and both a squared and b squared are perfect squares. So when we factor that out, the square root of a squared essentially goes in the front of our parentheses, and the square root of b squared goes in the backs of our parentheses with a minus and a plus. So if we're trying to factor 4x squared minus 9, the two things that multiply to make it are going to be, in the front of the parentheses, the square root of 4x squared is 2x, and 9 is a perfect square. The square root of 9 is 3. And we'll need a plus and a minus sign in there, doesn't matter where I put them, so that if I were to double distribute or FOIL, I'm going to get 4x squared minus 6x plus 6x cancels out, and then plus 3 times negative 3 makes negative 9. Next up, we have the sum and difference of perfect cubes. So now when you're trying to factor a binomial in which both pieces are perfect cubes, you have to look at the sign you're working with. If there's a plus sign between them, then the first set of parentheses has a plus sign. If your two perfect cubes have a minus sign between them, the first parentheses is a minus. And in that first parentheses, essentially the a and the b are the cube roots of the a cubed and the b cubed. So for example, down below, factoring x cubed plus 64th. Both of those are perfect cubes because the cube root of x cubed is x and the cube root of 64 is 4. And there is a plus sign in between them, so there's going to be a plus sign in my first parentheses. Now, when I go to do my second parentheses here, I look at it as x times what is going to make x cubed? Well, x squared. And then in the back, 4 times what is going to make 64? 4 times 16 is going to make 64. And to have it be a positive 64, it's going to have to be a positive 4 times a positive 16. And then in the middle, I know in this whole situation, whether I'm doing sum or difference of perfect cubes, there is one minus sign in the factors. Here, here, one minus sign in all of that. So in the middle, there's my one minus sign that I need. And then the middle is simply the product of the x and the 4, which is 4x. And again, you could always check this by distributing the x to all those pieces, the 4 to all those pieces, and then combining like terms, and it should come out to be x cubed plus 64. So after our special situations of perfect squares or perfect cubes, then we get into generic factoring, which essentially is what you learned back in Algebra 1. This equation, x to the 4th plus 20x squared plus 64 equals 0. We can factor this in the front. To make an x to the 4th, I'm going to need x squared and x squared. And then in the backs of the parentheses, I'm looking for numbers that multiply to 64 and add or subtract to 20. This goes along well after the last problem because 4 times 16 is 64, and 4 plus 16 happens to be 20. Now notice both of my signs are pluses in my trinomial, so both of my signs are pluses in my binomials. And this is actually an equation that we're trying to solve for x, so I have factored it. Now Mr. Squiggly is going to come along and give us the two roots of the two solutions, or actually in this case there's going to be 4 roots, 4 solutions. So x squared plus 4 might equal 0. When we solve this for x, we're going to get x squared equals negative 4. and x will equal the square root of negative 4, which is actually equal to plus or minus, pound out the negative sign imaginary, and the square root of 4 is 2. So 2 imaginary. There's 2 of our answers. And then on the other side, x squared plus 16 might equal 0. Subtract the 16, and then square root. We get plus or minus the square root of negative 16, which is actually plus or minus 4 imaginary. We can also factor by grouping. So this problem, we're not going to be able to factor it generically. There's 4 terms to it. It's not a trinomial. And also notice here, this is not an equation, so we're not going to solve for x. We're just going to factor it. So by grouping, we're going to group the first 2 terms together. They have a greatest common factor of x squared. And when I take out that x squared, I'm going to be left with 2x minus 5. And then the last 2 terms have a greatest common factor of minus 9. And when I divide minus 9 into both of those, we're going to be left with 2x minus 5. Notice we have a common term here, 2x minus 5. So we're going to pull that out of both of those pieces. And my leftovers are going to form my other factor, x squared minus 9. And if we wanted to FOIL that out or double distributed that out, it will give us the original expression. And again, no Mr. Squiggly here because this is not an equation. It's just an expression to factor. And lastly, a little long division. We want to see if x plus 6 is a factor of this big polynomial. So we have a binomial that I'm going to try to divide into this other binomial, 2x to the 4th plus 9x cubed. Essentially, I want to figure out what can I multiply x by to make 2x to the 4th. Well, I would have to multiply by 2x to the 3rd. And now I'm going to distribute that 2x to the 3rd to both of these terms. And I'll write the answer right down here. 2x to the 4th, 2x cubed times positive 6 is positive 12x cubed. And now I'm going to subtract. 2x to the 4th, take away 2x to the 4th is gone. 9x cubed, take away 12x cubed is negative 3x cubed. Next, I'll slide over to my next term and bring it down. Minus 12x squared. And now, I'm going to try to figure out what times x will make negative 3x cubed. Well, that would be negative 3x squared. And I'm going to distribute that back to what I am dividing by. So that will make negative 3x cubed minus 18x squared. And then I subtract again. Negative 3x cubed, take away negative 3x cubed, cancels out. And my squared terms, negative 12, take away negative 18, actually makes positive 6x squared. Slide over. Bring down my next term. Now, what times x will make 6x squared? Well, that would be 6x. And then I'm going to distribute that back to the x plus 6, which will make 6x squared plus 36x. And subtract. 6x squareds disappear. 32x take away 36x is negative 4x. And I think I have one more term to bring down here, my constant term, minus 24. And now I'm going back and saying what times x? X times what will make negative 4x? That would be negative 4. And when I distribute that back to the original x plus 6, that'll give me negative 4x minus 24. And when we subtract those, we get a big fat 0, which means x plus 6 is a factor of that polynomial. And I'm actually going to check this, because if I know x plus 6 is indeed a factor, that means negative 6 is going to be one of the roots of this equation. So if I go on my calculator and plug in negative 6 for x in all of the places you see an x, I use parentheses around my negative numbers, I should get 0 as my answer. And there you go, it does check out.